Okay, suppose this is number 3 for the test review. Suppose that an automobile manufacturer advertises that its new hybrid car has a mean gas mileage of 50 miles per gallon. So this is the claim. You represent a consumer advocacy group that believes that the mean gas mileage is less than advertised. You take a simple random sample of 30 hybrid cars. 30 is important because it tells us we can run this test. You find that the sample that in this sample, the average is 4.83 miles per gallon with a standard deviation of 5.7. Now they were nice and told you X bar and S. Normally they're not. They're just say the average of 48.3 miles and a standard deviation of 5.7. So you're not always going to have them lay that out that nicely. So you are going to have to read carefully to make sure that they what that is. It says test. So this tells me I'm running a hypothesis test at alpha equal 0.05, determine whether there's evidence to reject the advertiser's claim. So first off, what's the advertiser's claim? The advertiser's claim is that it's 50 miles to the gallon. So HO mu equals 50 miles. All right, there's no D because it's just, this is not a paired test. We're not testing the car twice. We're just testing a group. All right. Now, one thing I want to point out to you, you're probably going, how did I know to use 50 as to use 48.3? We never ever use the sample claim. We never use sample data here. Never ever use sample data here. That's a never use sample. And we will always believe the claim. Well, what was the initial claim? This just like in the court of law, we believe innocence until we prove otherwise. But we're going to try to gather evidence to see if it's something different than that. So we have mu, and then we have, once again, 50 miles. And so we have this question whether it's going to be less than, greater than, or not equal to. Remember, not equal to is typically a different. Well, here they say less than, so this is just going to be less than 50 miles. All right, so that's number 1. Number 2, we need to define our parameter. All right, so what was our parameter? Mu equal the true population mean. Notice I said mean, not mean difference. There's no D there because it wasn't paired. The true population mean gas mileage. Technically, it's the gas mileage for a hybrid, but I'm going to say the true gas mileage. I'll make it a little bit shorter for myself. All right. Then I need to go ahead, and I'm going to need to go ahead and write my conditions. Well, for our class, our conditions are assumed. And then part 3, I'm going to write my equation. So T equals X bar minus mu S divided by the square root of N. If we're given a list of data we need to input at this time, we weren't. So now it says we need to find our information. Well, our information is mu is 50. X bar, in this case, was 48.3. S comes 5.7. That's our standard deviation of the sample, 5.7. N, how many cars were there? They tested 30. And not that I need it for this one, but I'm going to go ahead and write it down anyway because it's good practice. 30 degrees of freedom is 30 minus 1. All right, so I'm going to plug into the equation probability that T and is less than, and like, how did I know it was less than? Well, because this was a less than. Whatever this symbol is, those that need to match. Probability that 48.3 minus my mu 50 over 5.7 divided by the square root of 30 equals, all right, well, I don't know what it equals, so I need to go ahead and run this in the calculator. So here we go. Stat, test, Well, this is the t-test, so we're at number 2. And we're not entering data, we're entering statistics. So I'm going to arrow over and press stats. Well, what was my mean? Well, it's not 10, my mean is 50, so I need to change that to 50. My X bar is 48.3. My standard deviation is 5.7. And my sample size is 30. This is going to be less than, because that's what they have there. And so that equals the probability that t is less than negative 1.633. So there's my t statistic, equals 0.0565. So here's my alpha. Excuse me, not my alpha. This is my p-value. So we've got my p-value, and they said use an alpha of 0.05. So here's alpha. My alpha is 0.05. Always make these the same size. So this has 1, 2, 3, 4 places, so I need to add 2 zeros. And I see 565 is greater than 500. All right, and remember, when we look at our recipe, if the p-value is greater than alpha, our decision is to fail to reject. All right, we fail to reject. So that's our decision. So now we need to write our conclusion. Our p-value is 0.0565. We just calculated that right there. What was our decision? We fail to reject the null. Be careful here. There is not sufficient evidence at alpha equal to 0.05 to suggest that the, what was our definition? True population mean gas mileage. That the true population mean gas mileage is less than 50 miles per gallon. Okay, so we couldn't reject this. Since we can't reject this, that means we have to go, you know what? Can't reject it. So simplified. We cannot say that the hybrid gets less than 50 miles per gallon. So we cannot say that the hybrid gets less than 50 miles per gallon. Why? Because here's what we said, there is not sufficient evidence to suggest that the mileage is less than 50. We can't say that. All right. You're like, well, wait a second. 48.3 is less than 50. Yes, but that could happen by random chances. It's not far enough away for us to say that it is. So this concludes video number 3.